Hi everyone, my last video got cut off as we were isolating our x and y values. So really quickly, to get back into this problem, we had the equations 3x plus 3y equals 1125, and then the equation 4x plus 2y equals 10. So we were getting y by itself here, and we had 2y is equal to 10 minus 4x. And then when the last video cut off, to isolate y by itself, we were dividing everything by 2. So y was equal to 5 minus 4x divided by 2 gives me 2x here. At this point, using substitution, what I want to do is to take this expression for y and replace the expression for y in the original problem. So it will look like this then. 3x plus 3, and then inside of this expression I've got 5 minus 2x is equal to 1125. So then I'm just going to multiply out in here. 3x plus 15 minus 6x is equal to 1125. And then I just need to combine like terms. So this 3x and this minus 6x will become negative 3x. And then when I subtract 15 over here from 1125, I'll end up with negative 375. From there, I need to divide both sides by negative 3. Divide by negative 3 here. And when we plug that into our calculator, 375 divided by 3, both of them are negative, it will become positive 125. That's our cost. Now in this case, we defined X as the price for the pumpkin spice latte, so we can just specify that here. Then what we want to do next is to take that value and use it to solve for Y. Now here, because we used substitution, we already have a nice equation to plug back into and solve for y. So we'll have y is equal to 5 minus 2 times the quantity, $1.25, because that's what we found earlier for x. This will become 5 minus 2 times $1.25 is $2.50, and 5 minus $2.50, that is equal to $2.50, and for our other drink, the caramel apple ciders. So those are our two prices, and that's all we're doing for that equation, was solving for the values of how much each one cost. Let's take a look at the next example. This one is a very, very common type of application problem. It's one of those that will frequently appear on ACTs and PSATs and college entrance exams. It's one of those most very typical systems of equations applications. So here it says a scientist wants to mix a 5% acid solution with a 25% acid solution to obtain 50 liters of a 20% acid solution. How many liters of each solution should be used? So once again, our focus is on how many liters of each different solution that we start out with should we be using to make this new solution. So let's go ahead and identify our variables. We've got an x and we've got a y, and those are always just going to be the two different quantities that we have. So first up, we've got a 5% acid solution. So since we're interested in amount, let's call that liters. So we'll have liters of 5% acid. Then we have our second type of solution, which is the 25% acid. So we can just say y is the liters of 25% acid. So you can imagine if you're working in a lab, you have two different chemicals like this. So maybe they're sitting in little beakers. And then one just has a label that says 5% and one has a label that says 25%. So you're interested in mixing them because you need a 20% acid solution. So that would mean this one's not acidic enough, this one's too acidic. So you're trying to put them together in a way that's going to give you exactly the right amount of acidity and the total volume that you're looking for whatever your experiment's going to be. So the first thing we want to think of is how can we set up an equation that describes the total number of liters? Well, that's going to be pretty easy because we have liters from one of the acids, liters from the other acid, and overall we want 50. So all we have to say here is x plus y is equal to 50 liters. However much we use of one, however much we use of the other, at the end of the day, we need to end up with that total of 50. Then we need an equation that describes our acidity. So of the liters that we have from x, it is made up of 5% of whatever acid we're working with. And 5% can be described as 0.05x. Then with our Y solution, the 25% acid, that acidity is going to be 0.25 times however much of that concentration, however much we use there. Then we're still going to end up with 50 liters, but the acidity of that total is 20%. That's the last value that we have here. So we have one equation that describes the total number of liters used, and then for each of those amounts of liters, we're just multiplying them by their acidity. That way we know what percentage of the solution is acid. So at this point, we really want to ask ourselves, should we be using elimination or should we be using substitution? My recommendation for these is almost always, anytime you come across a mixture problem, and this is a mixture problem because we're mixing things together, usually substitution is going to be easy because we have one equation that already just relates x and y. So getting y by itself here would be super easy. We can just say y is equal to 50 minus x. So let's just plug that in for this y right here. We'll have 0.05x plus 0.25 times 50 minus x. And then over here, we can just multiply these guys together. 50 times 0.2, if you plug that into your calculator, will give you 10. So what we need to do next is to just combine like terms. So we'll have 0.05x plus, here we've got 0.25 times 50. So we want to plug that into our calculator. And that gives us 1250 minus, after we distribute here, we're going to distribute there. So we've got minus 0.25x equals 10. So then let's keep combining like terms. I'll have 0.05 minus 0.25x's. So when we combine this term and this term, we'll end up with negative 0.2x. Then we want to subtract 1250 from both sides. So we'll subtract over here. And 10 minus 1250 is going to give me negative 2.5. From there, we divide both sides by 0.2, or negative 0.2. And so that's going to be the final thing that we plug into our calculator. X is equal to negative 2.5 divided by 0.2. And that gives us 12.5 liters. So that means from the 5% solution, we're working with 12.5 liters there. So to find the remaining value, so the amount that comes from the other solution, all we have to do is plug into this equation here. Y is equal to 50 minus 12.50. And when we plug that in, we'll end up with 37.5 liters, and that's going to be of the 25% acid solution. So when we do these kinds of problems, there's always going to be one equation, that's your total. However many of 1 liters plus however much of another liters is your overall amount. And then the next equation just comes from multiplying the acidity by each of the liters values. So we'll continue to practice these ones. I think that these kinds of equations or these kinds of problems can come across as tricky because unless you're working in a chemistry lab, you're not thinking about mixing together acids on a daily basis. So what we really just want to focus on is there's 2 unknowns. We need 2 equations. One equation always comes from a total, and then the other equation relates to money or percentage or some kind of financial amount.